This video demonstrates how TrueBench detects changes in performance and helps you to analyze why those changes occurred. Client metrics tell you what the response time was, but when it changes, the question is, why? The DBMS query logs can explain that, showing CPU and I/O usage, and what else was running on the platform. Without that visibility, fixing reliability and performance issues becomes trial and error. Finding your test activity in the DBMS query logs can be a daunting task. TrueBench maintains a test tracking table in the host DBMS, capturing precise start and stop times for each run ID and test name. It also inserts the query name as a comment into each SQL statement, allowing each log record to be tied back to a specific query. This correlates observed response time with database activity that produced them. This bridges the gap between test results and root cause. In this video, we'll analyze the performance of prior tests using automatically captured metadata, then show how test tracking and analytic views are set up in the host DBMS, and finally use those views to explain observed performance. We'll start with the list command to show recent test runs. From the prior video, we executed a test suite consisting of a serial test, a workload with 3 workers, a workload with 6 workers, and a final workload where we increase the percentage of light queries from 20 to 40%. Before we compare the runs, it's important to understand the role of the 2 types of testing we've been using. The serial test is designed to isolate individual queries. It helps us detect a change in the reliability of individual queries. The workload test, on the other hand, simulates realistic mix of activity, allowing us to observe how the DBMS and cloud infrastructure behave under competing demand. Together, they allow us to distinguish between changes in individual query behavior and changes caused by contention, resource limits, or competing workload. We're using the assess command to compare the 2 runs with the same number of workers, but a different workload mix. Total executions increase from 60 to 75. The difference comes from the light queries, increasing from 12 to 30, while the heavy queries remain about the same. The system didn't get faster. We changed how the workloads use the available CPU. In this case, we gave up a few heavy queries to execute many more light queries. You can also see that many individual queries ran slower, which is expected under higher concurrency and contention. This is why workload composition matters, not just the number of users or threads. If the test isn't realistic, every conclusion is questionable. Now let's look at how to link to the host DBMS to explain what the DBMS was doing during the test. In previous videos, we discussed TrueBench TDB startup script with before and after run statements and after notes commands to maintain a test tracking table in the host DBMS. Now let's look at how that is set up. Setup directories are provided for several database platforms. Each directory contains a set of scripts and a README describing how to enable query logging and analysis. Each README provides information about query logging on that platform, a description of the scripts provided, a recommended setup sequence, how to enable query tagging for identifying queries, and examples of how to use the resulting views. Together, these scripts make it possible to correlate test execution with database activity. Some platforms include more extensive examples, reflecting deeper system-level access and prior implementations. In this demo, we'll use the Teradata setup. The setup scripts create a structured set of analytic views. The first group extends the DBMS query logs, adding run ID and test name, so we can tie back every query to a test. The next group does the same for resource usage. And the final group provides higher-level reporting views. We'll focus on 3: report some runs, report some queries, and report system CPU. Report some runs provides a summary of each test execution, including elapsed time, query counts, CPU, and I/O. During an engagement, I typically paste this into Excel to track runs and compare behavior over time. Report some queries breaks the test down by individual queries. Here we're looking at a single run. We can see execution counts, response time, and the percent of total CPU used by each query. That makes it easy to identify which queries are driving the system load. We can also compare runs from different points in time to see exactly what changed at the query level. To understand why behavior changed, we look at system-level resource usage. I've already brought this into Excel to visualize CPU utilization across the runs. For the serial run, CPU utilization is only about 70%, leaving idle capacity. With 3 concurrent streams, CPU usage is nearly 100%. With 6 workers, the system is fully saturated. CPU is essentially maxed out. This explains why doubling the workers did not significantly increase throughput. And when we increase the proportion of light queries, we use that capacity to increase the total executions. This is the difference between observing performance and explaining it. Modern systems are composed of many components that are constantly changing, not just in the database, but across the entire ecosystem. When something shifts, the challenge isn't just seeing that it changed, it's understanding where in the ecosystem the change originated. With TrueBench, you can correlate what your workload experienced with the activities of the database and the platform. Because these tests execute across real application paths, they naturally include the effects of network and cloud infrastructure. That becomes especially important in shared environments, where platform-level changes may improve overall efficiency, but introduce regressions in specific parts of your system. This allows you to isolate issues that would otherwise be difficult to explain. TrueBench is now available as an open source project. You can download it and begin analyzing your own systems. The setup directory includes scripts for multiple databases and will continue to expand with additional platforms. This approach is designed to help you detect and understand changes across your entire information system, not just measure performance. TrueBench: simple setup, realistic workloads, efficient analysis.